Okay, so hi everybody. Monday's a public holiday, so we don't have a live lecture. So I'm going to make two recordings. I'm going to do part 1 and part 2. This is part 1. Okay. All right. So last week we did 2D arrays and strings. We didn't get up to arrays of strings or command line arguments. So I'll put these in the second video that I do. Don't forget, we don't have our lecture on Monday, but we also don't have our tutes and labs. So there's a link here that you can book into another tute and lab just for this week. And you can look up this timetable for different time slots to see what suits you best. And you can also get that link on the Ed forum. And also because our labs are usually due on Monday and, it's a public holiday, just for week 5, our lab will be due on Tuesday. So the week 4 lab will be due on the week 4 lab will be due week 5 Tuesday instead of Monday. Just for that week. All right, so in this first part, I'm going to just be doing a bigger 2D array of structs with enums program. So bigger than we'd normally have time to do in a lecture. And it's putting together concepts that you need to understand for assignment 1. And we'll talk a little bit about style along the way. And the second video will contain a recap of strings, talk a little bit about arrays of strings and command line arguments and multi-file projects. So some new stuff in that video. As always, there's live lecture code that's available. And let's get started on this example. So we've got a game called Mud and Bones. It's not really a game, but anyway, it's game-like. We've got a dog who's the player that's moving around on a map. And the locations on the map contain either grass, mud, or water. They may also contain a bone. The dog can move around the map and collect the bones. However, if the dog was on a location with mud in the previous turn, he will spread mud to the grass if he lands on grass in the next turn. If he was in a location with water on the previous turn, it'll wash the mud off the grass on the next turn if he lands on mud, and it'll turn back into grass again. So there's no actual winning in this game. The dog just wanders around and the player presses Control D to end the game. And this is not how mud, water, and grass interact in real life, but anyway, that's how it works in this. So don't try this with your own dog. The water will just make the mud even worse. All right. Let me move this up here. Ugh. Here are some important types and constants. So we've already got hash defines for the size of this map, which is 8 by 8. So 8 rows, 8 columns. And every cell on this 2-dimensional array that I'll show you in a minute has a struct location. So it's a 2D array of these structs here. And each struct has an enum item type and an enum ground type. So every struct can either be grass, water, or mud for their ground type. And every struct can either have nothing and be empty or have a bone. Okay. Now, this is the definition, like this is how we can declare our map. So we declare one of these. Actually, I've already got that in the code that we're going to start with. And you can visualize it as a 2D array, like always. We can visualize it like this. And if I've got 8 rows, I'm going to have row indexes from 0 up to and including 7. If I've got 8 columns, I'm going to have column indexes from 0 up to and including column 7. Now, if we kind of try and zoom in and look at these in a bit more detail, like I said, each one of these, and like you can see up here from the type, Oops. Yeah, this is a two-dimensional array that contains these structs. So each cell in this array that is called map is a location. And every location has these two members, one that is an item type and one that's a ground type. Now, just to remind you of how these types of things work when you've got structs in an array, first of all, you've got to go to the relevant index within the array. And I haven't managed to do that very well. So if I go to the map at row 0, this is row 0, column 1, I get this cell here. This cell is a struct location, right? So using the indexes takes you to the struct. But inside this struct, I've got an item field. So to get that, I say dot oh, this is what dot item. So once I get there, I go and get the dot item out of it. Okay, so I could go and set it, or I can check the value of it. But this is how the sort of indexes work with the dot fields or dot members. And, you know, map at index 0, column 1, row 0, column 1, if I go to dot ground, that has mud in it. Okay, so that's how we can access all the data inside this map. Okay, so we've already got code that initializes a map. So basically it goes through and sets everything in the map to have a location that has empty, so no bone, empty and grass to begin with. But then I've also hard coded in a few locations that have mud, water and bones scattered around. I decided not to get the user to enter them and read them in. I didn't want to write code that was, you know, too similar to what you're going to have to do in your actual assignment. All right. Print map. I provided a print map that prints out the array. You have to pass in the dog row and the dog column so it knows where to draw that onto it, and the number of bones and the mud spread. So this is how many bones has the dog found already and how much mud has the dog currently spread. Okay, so the first step is to create the map variable, initialize the map, and print the board, and that's already been done. So then the next step that we're actually going to do is to scan in the coordinates from the user to set the dog's starting position. If they type in something illegal like row -10 or row 100, which, you know, isn't legal, it isn't a legal index, we'll just set the dog to have a default position of 0, 0. And to begin with, there'll be some kind of, we need to maintain some sort of counter or variable for the bone count and the mud count, and set those to 0. And then we print the board. After that, we have a loop where the user can enter W, A, S, or D to move the dog around. So W's up, S is down, A is left, D is right, which is very common in these types of sort of games. Other input is just basically ignored, or we're not even considering it really here today. And again, I'm not implementing the bounds checking of the array, which means our program might crash, because if we keep saying, you know, go up, go up, go up, and we go off the side of the map, our program will have a runtime error. But that's something you'd have to handle in an actual assignment. All right, as the dog moves around, we've got to update the changes on the map, because if the dog, you know, is moving through water or mud, it's going to change mud to grass and, you know, grass to mud, etc. Also, the dog might find a bone. The bone has to be removed from the map, and then the bone count has to get incremented. And we also print out yum, if I remember. Then we print the map after each valid move. Although we're just assuming all of the moves are valid for today. All right. So let's go and have a look at this code. So we've got some hash defines up here, and we can put some hash defines here ourselves. So before I even get too far along, I want to put in default dog row. To be 0, because yeah, this is where the dog will go if no valid inputs entered for the dog's position. The other thing I want to do is put hash defines for all of those moves like WASD. So I'm going to have up, which is W. I want one for each because it's good to have these hash defined as constants as well, because otherwise these are also like magic numbers. Where a user is expected to, someone reading the code is expected to know what WASD means. It's good to put it like this. So that will be down, left, right. WA, I think that's right. Okay, so I just wanted to do those before I forgot. And, you know, as I'm programming, there might be more things that I decide, oh, yeah, that should be a constant, but they're ones that I just thought of before I started. Then there's the structs and enums I showed you. If we want to define our own for any reason, we can. These are the function prototypes that we'll need to use. There's a few other smaller ones that, you know, were used as well, but these were the two that we might have needed to look at or call. And we can create our own functions as well, and we should. We shouldn't have it all in the main. All right, so what happens with the code that we've already been given? Let's try it out. Oh, let me just, I don't think I've changed anything, but anyway, let's try it. Okay, so we've created our variable, our map variable. We've got one of those, and we're just going to be passing it around to different functions when we have to. And remember, it's an array, so when we pass it, it's not passed by copy. All the functions, if they're modifying it, will be modifying that original 2D array. So there's a function that initializes it. You can go and look at that in more detail later, but it's just setting things to be grass and empty and putting a few bones, water and mud around. And then we're printing it out. At this stage, we don't have any valid indexes for the dog yet, so we've just put invalid index there to show we don't want you to print the dog. And so far, the dog hasn't spread any mud or found any bones. Now, when we look over here at the board, so it prints out that initialized board, and then it's got a few printf statements, so we don't have to type them in later. But, you know, this whole thing here is one row. So every row potentially has two things printed on it. It might have nothing, or it might have a bone, and then it might have a dot for grass, an M for mud, or a W for water. And that's pretty much all it is. So there's 7 columns and 8 columns and 8 rows. All right, so that's what we're given. Now, the first thing we want to do is enter the dog's location. So to do that, we're going to need variables. By dog's location, we mean like the row and the column. And we can enter that using scanf because they're just going to be integers. Okay, so that's how we'd scan that. Now, do we want to just make sure that they're integers? We can do that. Or we could say if it's not that, they're not integers. And we also need to check that they're within the bounds of the array. So let's imagine that we're going to write something called like a function called isValidCoordinate. And that's going to take in our dog row that the user entered and our dog col. So if they've typed in -5 for the row and 100 for the column, you know, it's going to return 0. This is not valid. If they type in something sensible, we will get 1. This is valid, right? We haven't written it yet, but just imagine we do. So if it's not a valid coordinate, oh, what have I done? So either if they didn't enter even integers, or they entered integers, but they're not within the bounds of the board, and they're not valid, we're going to print out an error message. And again, you know, if this was an assignment, you've got to make sure that you're only printing things if you were told to print them. Here, this isn't a full assignment spec, so some of the stuff I'm making up as I go along. Invalid, I'll call it location. Oh, that'll do. And what do we do? Well, we just set it to be the defaults in this case. So we're not actually asking them again or anything like that. We're just setting defaults. Okay. So that's kind of the logic. Once we do that, what else do we need to do? Well, we've got some variables we need to set. So the number of bones should be initialized to 0. And the number of, the mud spread should be equal to 0 as well. Then we want to print the map. And now we know where the dog is. The dog is at dog row and dog col. And also we know that it's at num bones and num mud spread. Okay, or is it the other way around? Ooh, let's check. Oh, yeah, it's num bones first and then mud spread, which is a bit confusing because I think it's printed out the other way. Oops. All right, so now let's try and write isValidCoordinate. So it's just going to return 1 for yes, it is a valid coordinate, or 0 for no, it's not. And it takes in, well, we might use it. Let's just call it int row and int col. We might use it in other places where we're not talking about the dogs row and col, although maybe not in this simple sort of scenario. So how would we do this? Well, if my row's valid, a row has to be greater than or equal to 0, and it has to be less than, you know, the maximum. So if there's 8 rows, it can't be 8. It has to actually be are less than it. But then we've also got our col. So if our col is greater than or equal to naught, and less than map columns, then that's valid. So if all of these things are okay, then we know our input was valid. Okay, and we'd return 1. Else, we're going to return 0 because no, if any of these things weren't true, then this is not a valid coordinate. Hopefully that's right. That's something we're really going to need to test though, to make sure. But let's try this out. So let's compile it. Let's run it. Enter dog's location. Let's do 2, 0. Yeah, why not? Yep. 0, 1, 2, column 0, and there's the dog. Okay, now what else did we want to check? And it's saying mud 0, bones 0. All right, what about if the dog's location is -1, 5? Yep, it said it was invalid and it put it in the default position, but this is something you'd want to check more thoroughly, all the different cases, not just, you know, what about if it was location 0 and 8, sorry, 8 0. That should be invalid too. You know, you'd want to go check all the possibilities. All right. Now, are we happy with this, or did we want to break this down into functions? Or did we want to potentially, you might want to put all of this information about a dog into its own struct. Let's say we did want to do that. Now, you might choose not to, or you might, you know, structure things differently. But imagine we decided, yeah, I want something to contain all of this dog information. We could do that. We could say dog data. Oops. And we could have, what would we have in it? We'd have int row, int col, int num bones, int mud spread. And maybe we work out that we need other stuff in there later. I don't know. It's good if we can try and work that out in advance, but sometimes as we go, we might decide actually, you know, I forgot about, you know, X, Y, Z. So dog data was the name of our struct, and I'm just going to call it dog. So now I've got a struct called dog that has members for the rows and columns. So don't need those individual variables now. Instead of having a whole variable for the dog row, I just say dog.row because that's inside my dog struct, dog.col. Okay, dog dot, I could probably do this in a better way. Okay, and all right. Oh no, there's more down here. Yeah. Okay. And also these are in the dog too now. So this would be dog dot numbones and dog dot mud spread. Dog, dog, dog. Now, ideally, this does exactly the same thing. And what does this give us? Well, we might be passing this dog around to different functions and it can make it easier. And it just puts it all together. Not 1, 2, 3, 4, 5. Not 1, 2, 3, 4, 5. So yeah, we'd want to check this thoroughly. We even might want to run a style checker on it at this point. White space on line 80. No ZID, that's okay. I don't really want to have my ZID. You need to have yours though. Okay, that looks good enough for now. We might think about whether we wanted to put some of this in other functions actually. Let's try and do the next thing. Now we definitely want to put the command loop in a function. We don't want to have everything in this main. I'm going to call the command loop that's looping around getting user input to move the dog around. I'm going to call it find bones. And we need to pass the dog and the map in. And I don't think it has to return anything. Again, we might realize that's wrong and it's not going to work, but that's how I'm thinking so far. Oops. Okay, so it shouldn't have to return anything. Okay, what are the types? Well, this is the map is struct location. Oops. Oops. My goodness. Okay, and this is struct dog data. Okay, this is a bit too long. I know that the style, because this line here, you probably have it set up as well. This line here is telling us that we're over, you know, where the 80 mark is. So I can see that I'm over. So I might just handle that now and do it like this. Okay. So let's think about this find bones function. So I've already written a comment for it, just to remind me of what I had to do actually. So this is the command loop, and the user will be entering, you know, A, S, W, or D. And we're going to be just continually reading that in. Now, I'll put %C here, but I'll show you that that's probably not what we want. So while this is still giving me a 1, the user's still entering characters. Okay? And what could those be? Well, the command could be equal to command up, or it could be equal to command down, right? Oh my goodness, I can't type. Equals equals. Oh my gosh, what have I done wrong? Okay. So we've got up, down, left, right, and then nothing. We don't just want to say else and just handle things that aren't meant to be there. Actually, I might put an else just to help myself debug it in case, you know, so I'm not confused. Okay, but, you know, if this was an assignment and I wasn't told to do that, I'd want to get rid of that before I submitted it. So what does up, down, left, and right do? Well, if we think back to the grid, you know, if I'm like here and I move up, my row is decreasing. My column's the same, but my row is decreasing. I'm subtracting one from my row. If I go down, I'm adding one to my row. If I go left, my row's the same, but my column, I'm subtracting one from my column. Right, I'm adding one to my column. All right. So it's good to kind of think about that before we just launch into programming. And here I'm not checking whether these are valid. I'm not checking because I could be in row 0, and if I try and go up, I'm going to try and go to row -1. So you should really check for this sort of stuff. Here I'm not, and I'll show you what happens when we don't do it. So here, if we go up, row is decremented. Oops. Okay, left. Yeah, here, if we go down, row is incremented. Going left, col is decremented. Going right, col is incremented. I hope. We'll see though, won't we? And then I need to print out the map. So at the end of each sort of turn. Now, obviously we haven't implemented everything here, but we just want to see if we're moving around okay. So let's start the dog off at 0, 0. And let's just see if it can move to the right. Yep. And it can move down. Yep. To the left. Up. But as you can see, obviously we haven't implemented anything to do with the water or the bones or the mud yet. We're just moving around the board. And if I'm on the edge of the board and I say move left in this case, what's it going to do? Oh, it's just moved me off the board. Okay. Later, once we do more coding, we'll probably end up crashing things. Oh, yeah, and I forgot. I should have, the whole point is to I can also just press, I can, move around a bit. When I want to end, I can press Control D. That will let me exit out of it with this kind of loop. Now, the thing I just noticed here, not valid command. When am I getting that? Let's try that again. So I'm typing in the dog's location. Let's just make it 44. And it's already got up here, not valid command. And all I've typed in is 44. So this is that old problem. I'm not just typing 44, I'm typing 44, enter. So I've got the new line character and scanf %C is reading that in. So in this case, I really want to make sure I've got that space there if I want to just skip through new lines and spaces, which I do. So if that's what you want to do, that's what we should code up. If it's not, it depends on what you're trying to do. So let's just try this one more time. I'm at 0, 0. Okay, I can move around. Okay. Control D out of it. Now let's try. I want to update the bones. So if my dog has just moved onto a location with a bone, I want to increment the bone count and also remove the bone from the map. So I'm checking whether the map at the exact row where the dog is after it moved and the exact col where the dog is after it moved, if the item in that is equal to a bone, well, the dog has just found a bone, which is great. I increment the number of bones and I want to make sure I don't leave that bone on the map because in this game, the bone should be gone. So we need to set it to empty. We've taken that bone away. Okay. Let's just try that now. We don't want to write too much code without compiling it and checking it. All right, let's just start at 0, 0 and move our dog to the right because I should get a bone. I got one bone. Has it been taken away off the map? I'll go down and yep, that bone's missing and my bone counter is now up to 2 because I've gone through 2 bones, etc. Let's see if I can go over here and get this bone. I'm going to press Control D now. Okay, so it looks like we've implemented the bone counting okay, but we haven't implemented the mud and the water. So we need to do something similar. So if I'm currently on grass, but the previous, like before I moved, if before I moved I was on mud and now I'm on grass, that grass becomes mud. How am I going to know where I was before? Well, I need some way of storing that information. Whether I store it in my dog struct, whether I have just a variable here, I need something that's saving that where was the dog before or what ground was it on? That should be enough for this, right? So ground type, previous ground. So I'm just going to get the dog. Oh, I'm just going to find out what ground the dog was on before it moved. So up here, the dog hasn't moved yet. I'm finding out what the ground was on the map where the dog was. Okay, then the dog moves, but I've still got that variable, so I can still ask, okay, well, what was the previous ground before? If I'm on grass now, but I was on mud the last turn, well, now I've spread mud to this particular cell. And I need to update my counter. Like that. And you've got to be careful you're not in a scenario where you change grass to mud, but then you change mud back to grass in the same sort of if statement. This isn't going to happen here, but just in general. So we want this to be an else if. So, okay. Oh, it's not item. Oh, it's ground. Ground. All right. So if I'm now on mud, but I was previously on water, and now I'm going over the 80 threshold. So I'm going to need to space it out differently. All right. All right, trying to decide how to space it out. Actually, I typically like to have it like this. Anyway, that's just me. All right. What happens in this case? Well, the ground that you've landed on that was mud, it gets washed by the water, which makes no sense at all. But it turns back into grass. Okay. And that's, that decrements the mud spread. It's gotten rid of mud. All right, so we're moving around, we're reading in these things from the user, moving the dog around and updating the mud spread and updating the bones. And this is pretty much it. So dog location, 4. Okay, let's try it. Oh, this isn't the greatest place to go. There's not that much mud. Let's head up the top. Okay. Now, the mud doesn't get spread to water. Did something wrong happen there? What was the... Oh no, there was never any mud on this row. Okay, gosh. So if I go up, 2 things should happen. I should get a bone, but now I've just stepped in mud. So now wherever I move, I'm going to drag that mud around if this works. Yep. And I'll go down. I'm dragging my mud around. Now, if I go down now, it doesn't drag it onto the water. But if I go up again and I've just been in water, it'll get rid of that mud. But it won't keep doing it. It only does it once because now I'm on grass. Yeah. So that looks about right. Let's try again. I get on mud. I go and get that bone, but I've spread more mud. Oops, I didn't mean to do that. Oh yeah, that's water. So, okay. Oh dear, my brain is hurting now. Let's go to the right. It should get rid of this mud. Yeah. And it's decremented it. Okay, so I think that kind of does everything that we wanted it to do. I sort of set out to leave you hanging with you needing to, yeah, it crashing when you go over the bounds. But I think that's about it. Now, in terms of how this is structured, could we break this down more? Yeah, like I could, I'm not going to have time to do it all now, but I could even put this here, I could create if I wanted to. Let's just do this one. Struct dog data. Initialize dog. And yeah, maybe void. So I could kind of move all of this stuff into here. I'm actually creating a dog struct in here. I'm getting all the information, and then at the end, I'm returning it. Okay. And up here, I'd have to call that function, and I'd say initialize dog, like this. So this is like, initialize map, print map, initialize dog. I mean, we could even move this message into it, right? Print map. We could put this into find bones too. And then up in main, we end up with just a really short main that reads like a list of, you know, a to-do list sort of. It just reads like, okay, do this, do this, do this. And they're sort of high level function names. So we don't have too much detail to get confused by when we're just looking at the main. Oops. Mud and bones, mud and bones. Now the idea here is to check that we haven't broken it by moving things around. Okay. But I'm not checking it properly at this point. All right. And again, we should have some kind of comment here. I'm not going to have time to clean this all up perfectly right now. If we have a look at find bones, yeah, we could also clean up some of, like we could also break this down into more functions as well. I could have a function that handles the moving of the dog. I could have something that handles, you know, the other updates to make this shorter. How many lines is this one? I don't think we've got time to do it now. Let's just have a quick look and see what, again, the style checker is telling us. Oops. Yeah. Honestly, I probably would break this one up, move this into a different function. But look, let's just do it quickly. So imagine you just, and you, look, this isn't necessarily the best way to do it, but imagine I wanted to move this into a function called move dog. So I'd pass in the command that I was given, and I'd pass in maybe the struct dog data, and I'd pass in the dog. Right, because you might try and do something like this. And over here, you just call the function move dog, and you're passing in your dog, and you're saying, I want you to move it. Now, of course, I need to put the prototype up the top. So you think, yep, that looks better now. This, you know, the style checker was complaining at me because it was saying my function was too long and I've moved it and I'm really happy now. First of all, what have I done wrong? Why is it not compiling? Oh yeah, I haven't passed in enough arguments. I've got to say, you know, what did the user type in? Like up, down, left, right, and I've got to pass in the dog because I want it to move. So let's just try this. It compiles. Let's see if it works. Okay, we're starting at 0, 0. Let's just move the dog and check this is all still working. Oh no, my dog is not moving. What's going on? So this might happen to some people. Remember, if I pass in a struct to a function, it's not going to change the original struct. So my original dog struct will be exactly the same. Okay, it'll change the local copy. So for something like this, you've got to make sure you pass back the updated dog or the updated struct. So at the end, you return this updated dog. Now, this is probably complaining, oh, it's called dog data. The struct is called dog data and the variable is called dog. So where is it? Oh. Struct dog data. All right. And then you've got to make sure as well, if you do something like this, that, yeah, then you say, well, dog equals move dog, right? Otherwise, your dog, only the copy of the dog was moving. Your original dog was in exactly the same spot. Now let's just check this. Put it at 0, 0. Let's move it to the right. Yes. Okay. Control D. Now look, I haven't gone through this and perfected it like I would if this was my assignment with, you know, a great deal of marks. But I hope this has given you an idea of, I don't know, some of the things that might be relevant when you're sitting there doing your assignment. Also note that I didn't just type in everything and then compile it once when I'd finished. I'm testing out the little bits I'm implementing as I go. And yeah, I've left out a few comments I haven't written and, you know. So that's that. Was there anything else? Oh yeah, so for you, yeah, remember, do break your code down into functions. And I think there's something in the lab where you've had to do that, so that's good. Yeah, hash defines for your constants and for magic numbers, and that also includes things like WASD. Comments, you should have comments before every function implementation. The line length, I know that can get annoying, but hopefully, you know, you saw me today as well having to deal with that. You can get feedback from the style checker. That's not going to find everything. So check through the style guide and also ask your tutor in your lab or a help session, what do you think of the style? Or you might have one particular question. Is this comment okay? Do I need more comment? You can ask for feedback. Okay, but I mean, don't wait for, you know, the day before it's due and 1,000 people try and go to the help session to ask for feedback. So try and ask for feedback before then and get on it soon. All right, that's it for this part of the lecture. Part 2, I will post separately. So if you got through all of that, well done. And yeah, you can go check out, I've got the starter code and sort of the finished code that I did today. I'll have that in the directory that you can access and play around with. Hey, thank you. Bye. Oh, maybe feedback. Yeah, if you want to give feedback about this, please do. Okay. Stop that and